Right. Okay. Thanks everyone for joining another week. I have a hard stop today at noon, so I would have to end the meeting at noon. So I don't want to go through this quick so Joe can fully cover the paper we're going to talk about. So it's this paper here that a lot of you are on, but I figured it'd be nice to have Joe give us a synopsis of the paper and what we've talked about for people who weren't familiar with the paper. So stay tuned for that in 10 minutes. I said we're trying to organize this meeting with some people here, but it's about infectious diseases to space. And Paco had, which a lot of you guys know, had organized a regulatory RNA meeting when I first met him 4 years ago now in 2019. A very nice meeting. It was very small, like 200 people at the Science Museum. I was thinking of the same place to have it at. So we're looking for sponsors. There's some options brewing right now. But if you guys know of any sponsors, it's going to cover any kind of RNA kind of things from non-coding RNA to microRNAs but this is kind of the agenda so far we're thinking of. So if we get sponsorship, probably invite a lot of you folks to come. Let's just go to the recent news. This paper had come out here in Nature Comms, and then there's a little article in Nature talking about this paper. So this paper was talking about evidence that even though you're vaccinated and you might have immunity, the longer, I mean, it might not seem like a very, novel thing, but it wasn't really actually ever thoroughly shown until this paper came out. But the more exposed you are, even though you're vaccinated and might be immune, you're still going to be susceptible to, have a greater exposure to vulnerable for infection for SARS-CoV-2 infection, as we were seeing happening these days. And then in this article, as Kiko says, yeah, I mean, we know that this is a case, but this gives it even more importance for improved ventilation indoors, masking, and things like that we all know to prevent infection, especially with what's happening now. So this is just the paper that really went over this kind of experiments today with exposure, looking at the particles, looking at infection rates, and so on, which leads to our tool, the COVID-19 exposure assessment tool that Brian Schmoller and folks here had came up with, which is here. And I recently was talking to some of the NASA safety folks about how to properly modify this tool, because in the past what we use is the daily case numbers to predict exposure. But of course we know now that those numbers are not very accurate anymore because no one's reporting it like it used to. So I'm starting to talk to Adam Busheri, who's I think at a conference, so he's not. Oh no, he's here. Adam's here. Good. So I was emailed him. So I think we're going to start thinking about ways of how would you truly translate wastewater to number of cases? Because that, as he said too, there's some papers out, but there's not very good solid conversion rate. So that like for example, I found this is a nice wastewater site here in San Jose that actually overlaid when there was actually good case reporting, and then the wastewater, there's the green and the case. Wastewater is red and the case reports are the green. Sorry, other way around. So here's still the case reporting is like basically one-to-one match, but now obviously when it starts going here, case reporting become less and less accurate, but you can see what the wastewater does. So how do we translate this, and then how do we incorporate this in our tool, and then how do we actually maybe make informed decisions that way about your potential exposure risk, since case numbers won't be very good now anymore, accurate for this tool. Which leads to, of course, this to be a concern with the BA.2.86 that I talked about a couple of meetings ago. The new variant that's still low, but what people are saying, I think you've been following the science Twitterverse that people post things on and other things that within the 1 week it's doubled. And within another week, it quadrupled. So it's going up at a pretty high rate. So people are worried about this highly mutated variant. One interesting fact with this now is not with this variant, but interesting. This paper came out a couple of days ago, talking about how the white-tailed deer population has SARS-CoV-2, the free range has accelerated evolution in those. But this paper just accepted, came out. So keep in mind this was data from November 2021 to March 2022. So, now the media talking about this, or some news articles, they're extrapolating what might occur, based on what they found in this highly evolved mutated population in the deer population. And so people are interested in seeing how SARS-CoV-2 can potentially propagate through the deer wildlife, and how it might go from deers to human, and then maybe vice versa, which is only deers to human they're talking about. So, but then they speculate how can it go back if it can, if it does highly mutate in the deers. So long COVID news. I'm ripping through this so Joe could have enough time to talk. Steve actually brought me up to this article here from the New York Times, and I found it. Thanks, Steve. So this was a really nice article talking about, imaging. They've done CT scan over some long COVID patients and their lungs and the damage that it's done to these patients who are, the patients they talked about, I think, more severe COVID cases early on the pandemic. So they're on oxygen, and now they can't do what they used to do, for example, but they're on constant oxygen because of their lungs, and it has images like this showing how much it ravaged the lungs and destroyed it. But it's a nice article to read. The link's there. I'll send you, share the slides with you. And this paper just came. They're talking about linking clotting, which we know clotting can be associated with, long COVID, and it's been long. There's been many papers out talking about how COVID does blood clots and so on. But in this paper, it's linked to the brain. They basically figured out, a large study of people looking hospitalized, with COVID early pandemic. Basically, they identified these two factors, fibrinogen and D-dimers, might be potentially linked to this clotting and causing the cognitive deficiencies after a year. So this is the paper. There's some little snippets from this Science news article or summary article I was talking about, this Nature Medicine paper. But the patient population was about 1,800 patients, sorry. And then they basically had a 6-month follow-up, and then, within the year, and then they basically looked at these factors. They looked at the clinical outcomes, and they also looked at the specific, fibrinogen and D-dimer in the patients, subjects, and then correlated it back to the cognitive deficiencies that they had. So in a nutshell, basically, it said the blood clots that potentially happened 6 months, 12 months after COVID, and these patients were hospitalized too, so they're more severe, that these may be potential key things play a role in the clotting, which still might be detrimental to the long COVID patients 6 to 12 months and cause the CNS or cognitive issues that we see them having.
And option, this is Kevin.
Oh, yeah,
so did they look at any other clotting factors?
I don't think so. So I looked at it quickly, but they looked at from their analysis, they said these are the two main ones. So they looked at other ones and they said these were probably the two main ones that popped up. So, and then they focused on those from their analysis.
Because
there's probably other ones out there, yeah. But
there have been recent reports of other clotting factors having significant roles in cognition and dysfunction. So.
Yeah. So I'm sure there's other. They said these are the two major players, so I'm sure they looked at other ones, but this is the one that popped up.
All right, thanks.
Yeah. And then this one Lancet article was talking about, people are thinking long COVID, just in case it's a nice little article talking about how long COVID and in low income and middle income countries is actually a big issue that people might not be aware of, because these people are not necessarily as categorized with long COVID because they don't have the resources, let's say, the higher income countries do, that, if you go to your doctor, it might be diagnosing you that. So it's an interesting article talking about how this, in the years to come, this is something to think about, on how this could be impacting millions of people in these kind of countries, and how solutions to potentially, help them out. So people understand. And then this is an interesting article here from this paper talking about how COVID-19 for infants who are during this time, they have this change in the microbiome diversity. So they're saying the gut microbiome has been reduced, which is not a good thing, in the kids. So this paper goes into that, comparing, the infants' gut microbiome before and after the pandemic. And then, so the key facts were like, the infants born exhibit a lower alpha diversity in the gut microbiome, so fewer bacteria present. And then, they looked at the stool gut microbiome. These are the populations they looked at. And this could potentially, impact these factors here. Altered breastfeeding and so on may influence these factors. So it's an interesting read. So people are interested in the microbiome changes and how that might have impacted babies during the time or infants. This is another article talking about that.
And Austin, this is Kevin again. Were infants exposed in utero, or
I didn't read the paper in depth. I don't think so, but I could be wrong. I didn't.
okay.
Yeah, so I kind of quickly went over it. I think there were yeah, there weren't in utero, if I remember right. But that's another interesting question. Yeah, well, say more. Um, okay, so that's going quick to give Joe enough time, but the variance again is the if you know the EG 5.1 and the XBB.116 are the ones that were becoming dominant, but as you see here, we still don't see the the new variant as we talked about here, the BA.2.86, because the numbers are very low, not popping up as a high percentage yet, but people are keeping an eye on it because of the highly mutated version of it and how rapidly it's quickly taking over the population. So then you look at the wastewater, it's been rising nationally in the U.S. You can see it's going up, sort of plateauing there. And if you look at certain regions, I always look at where I'm at, but you guys could go to your counties. You can see there's a dip there going up, and now there's a dip again going back down. So keep an eye, depending on the county you look at, it's still going up or similar trends as we see. As I said, EG.5 is the one that's, if you look at the CDC trackers there, again, we don't see the BA.2.86 yet here because it's just very low. But people are speculating in the next weeks to come, you might see a quick overtaking of that depending on which way it goes. Right now, it's sort of a variant soup, as you see here, but EG.5 is the one that seems to be dominating. And again, the case number is going up. Case reports not very accurate, but you can see the hospitalizations also in the U.S. at least is keeping track of that. You can see that's actually rising in accordance with what we're seeing with the wastewater. So that's something to keep an eye on. Granted, when you look at the overall scheme of things from the beginning of COVID, it's still low, but people want to keep an eye on that.